We'll let that roll for a little bit, make sure that the stream catches up. All right. And we are live. Tim, if you can throw my little video bubble up on screen. Yeah, never mind. All right. Well, welcome to the May 2026 edition of Merge PHP. I'm here live at Austin PHP Meetup, but we're represented by folks all across the U.S., Kansas City, Vegas, Vancouver, San Diego, Portland, Seattle, Phoenix, Austin, Boston, Atlanta, Utah. So wherever you are, whether you're in person or watching this online, welcome. And here's our lovely logo wall. And I'm going to go ahead and hit the no more video thing. There we go. So if you are interested in JetBrains products, whether that is PHP Storm, PyCharm, Golang, IntelliJ, RubyMine, or any number of others, JetBrains is raffling off licenses. Shoot an email. I think we have at this point multiple of them available from previous months where folks did not actually claim a license. I still use PHP Storm as my primary development environment. The IntelliSense in it is great, and I think I've been using that for the past 13 or so years now. So if you're interested in that, then send an email over to chris@atlantaphp.org. That will, like, first one in or second one in or third one in, gets the license. Oh, we're going to refresh this because I think this was working previously. Oh no. Boom, boom. There we go. All right, so PHP 8.5 is the currently active version of the runtime. And if I click on the correct places rather than the wrong ones, you'll note that we have a few versions that are currently receiving active support, 8.4 and 8.5, as well as 8.2 and 8.3 for security fixes. If your Linux distribution backport security fixes, you may still be okay if you're an older version, but realistically, you want to be on at least 8.2 at this point. And since 8.2 will go end of life at the end of the year, I would say a bump up to 8.4 or even 8.5, because 8.5 has been out for long enough that it's fine. And the upgrade pain from previous versions is minimal. So there are a lot of upcoming conferences and events, starting with PHP Day happening, well, almost right now in Italy. Then next week in Chicago, we have PHP Tech. Then a different day, over in France, Laravel Live Japan, Symphony Day, WordCamp Europe, IPC Berlin is in June. JetBrains PHP versus Online. Symphony Online is, well, online. Web Summer Camp. Got Laracon in Boston in late July. Drupal Camp in Phoenix. Laravel Live, Drupal Camp Colorado, API Platform Conference, DrupalCon, and then pleased to announce that Longhorn PHP is coming back as a 2-day conference. That's 1 day of conference, 1 day of tutorials later this year in October 15th and 16th. That's a Thursday and Friday, same venue as before. Other than skipping Saturday, this year, same format as before. One of the nice things about doing a 2-day conference rather than 3 is conference prices are a little bit lower. Sponsorships are a little bit lower. And we were seeing that Friday was our best attended day. So it made sense to kind of keep it with Thursday, Friday. Apparently, we've got a Joomla conference in the same place and almost same time. So I have some emailing to do there. And then IPC Munich, WordCamp Canada, Netherlands, Laravel Day, and SymphonyCon round out conferences for the year. So we've got a lot of things going on, although a little bit more limited set of conferences for the US in particular, for PHP in particular, but a lot of CMSs have come back on their conference circuit, which is great to see. So when I remember to post things, which I'll probably do that here in a minute, we are on various socials. The most reliable of them is YouTube. We're also on the Fediverse, on the PHPC social server, and occasionally post something on the website formerly known as Twitter. Next month, we'll see if this holds.
Ian, can you reload? Reload the page. We have a confirmed talk from Mark.
Sweet. Boom. All right. So next month, we have Neighbor Gall talking about AI-assisted development, which we'll see how this talk compares and contrasts with the one that I would have given this month had Andy not stepped in. But we'll see that one Thursday, June 11th. If you have a talk idea, we do have spots later in the year on our schedule. mphp.io/speakers, or you can ping us on socials if you would like to speak at Merge PHP. Finally, we're going to talk about data structure databases, which are actually a lot more fun than it's like, oh yeah, just put a cache in there, put a TTL on it and move on. Redis and Valkey can do a whole lot more than that. And at that point, I'm going to turn it over to Andy Snell, because it's his talk, not mine. Let me do this. There we go. All right, Andy, take it away.
Excellent. Well, good evening, everyone. As Ian said, my name is Andy Snell. Over the next 50 minutes or so, we're going to cover some data structures and how they work with Redis OSS compatible databases, how it's more than just a good cache. We'll look at some concrete patterns, rate limiting, distributed locking, and dealing with membership at massive scale. And of course, because it's 2026, we're going to talk about how this whole category of product relates to AI and how we can use more AI in this area. My first experience with Redis was as a key value cache. I've been a PHP developer for about 15 plus years now, and I think it was with a Laravel app around the Laravel 5 era that I just added Redis because it was easy through Homestead at that time. But calling Redis a cache is like calling a Swiss Army knife a bottle opener. It's true, but it does not tell the whole story. Redis, Valkey, and other what I'll call Redis OSS compatible databases, and we'll get to that, are full-on databases. But they're a little bit different. They're not relational databases in the same way that MySQL or Postgres are databases. They're not document databases as Mongo might be a document database. To some extent, that's actually changed a bit. The shift from cache to data structured database focuses on the fundamental unit of the database. Now, in MySQL or Postgres, you have a table. A table has a row, and that's the only structure you're going to get. Mongo with database, or the document database, we're talking a JSON document. Now, these Redis OSS compatible databases by far have a number of different structures, and each structure has different functionality that make up their tooling. Redis has 18 of these structures. And what is a data structure? It's just a way of organizing data so that specific operations are efficient. And if you have a computer science background, and I don't, these are the things that they drilled into you in CS 101. Things like a list, a hash map, a set. For us PHP developers, that's associative array, associative array, associative array. Because we tend to use our array as kind of a universal data structure. But if we thought about it in the individual things that an array can do, it can be iterated over sequentially, that's a list. You can access it by key, that's a hash map. And then it can be used for unique membership, and that's a set. Those are the kind of things that we're talking about. And a step away from that, you get into queues and stacks. And so these are things that you already have in your application, but they're living at the application level. Now, what happens when your database speaks that same language? In traditional database, you translate your data, your structure, into the structure they have. If you have a MySQL or relational database and you have a hash map like a PHP array, you're going to flatten it out into a row. If you have a queue, you'll simulate it with a table and a status column. If you needed a sorted leaderboard, you're going to be using that same table, and you're just going to have an index on one of the columns and use that for your order. That's kind of a solving every problem with a hammer approach. It's not necessarily the structure your application needs. There's no optimization that you get with Redis or Valkey. At the same time, we're not talking about just key value stores. Memcache is a key value store. DynamoDB is a key value store. You put a blob in, you get a blob out by key. Redis, Valkey, the other Redis OSS compatible databases are key value stores at heart, but they're a little bit more. They have functionality around those values that give you functions, the same way you have functions in your application layer. So this lets you use the right structure for the job. For membership checks, we can use a set. For leaderboards, we use a sorted set, which maintains the order and allows for really fast lookups of the min, the max, and combinations. For queues, we can use a list, a doubly linked list, if you want to go CS 101, where you can push and pop from either end. And even if we're just talking about a key value string, the strings in these Redis OSS compatible databases have functionality you don't find elsewhere, where operations are atomic and race-free, where you can have a string that works as a counter and increment that string from 1 to 2 to 3 to 4, and getting the assurances that even in a distributed environment, you're not going to overwrite that number with the same number, or end up in a race condition that breaks your application. Using a database structured database gives you this choice at the infrastructure level, not just in our PHP application memory. And because these are optimized for the right structure, we get the advantage of the right big O. And I'm just going to talk about this briefly, because if we talk about these structures, we have to talk about big O. In general, big O is a measure of the time complexity of an operation, but it's not actually time. It's essentially the rate at which the complexity of the operation increases as the number of items grows. If you have in a MySQL table, which has a B tree index, it's well indexed. If you put more objects into that, more rows into that table, the time it takes to look up a particular primary key in that table grows at O log n, because it is a B tree, essentially a version of a binary tree that allows for more efficient lookups. Redis and Valkey, for essentially these key value lookups, they are optimized for O of 1, which means no matter how many keys you put in the database, you could have 2 to the 32 keys in a Redis database, and it should take the same amount of time as a database that has a single key in it, which is really, really fast. Now, I should mention, it's not a guarantee. You can't necessarily compare two distinct operations. Their big O number, their big O structure, because in theory, you could have one constant time O of 1 operation take longer than a O of n linear growth operations for something totally different. It's not a one-to-one comparison. However, because we're talking about highly optimized in-memory databases, it should normally be faster than looking up something in a MySQL database. Now, that fits PHP shared model perfectly. So in PHP, we have a shared nothing model. Every time you start the request, it's fresh. Now, except maybe if you're in a Franken PHP worker situation, or you're testing out some sort of asynchronous PHP. But in general, if we're talking PHP FPM, we're talking every request is fresh. There is no persistent in-memory state between requests. When that request is done, the memory is gone. So we have taken advantage of that, and that's actually one reason PHP has been such a great language over time, is we don't get the same kind of bugs you get when your process lives a long time and you have to worry about data crossing boundaries where it shouldn't. Redis can act as that memory for PHP processes. In general, like PHP Redis has the PHP extension for Redis has pooling connections, can take advantage of connections that are pooled. So we're talking really fast connections. And if it's even local, we're talking port-to-port type communication, where your PHP application essentially gets memory, has the shared memory through your Redis connection. Now, even if Redis didn't have any other features, and we're just talking about using it as a cache, that would be worth it. Don't get me wrong, Redis makes for a fantastic cache, and the drop-in support you get from PHP Redis to use it as your PHP session backend. If you're using PHP sessions, is just so easy to use. And if you're using Laravel or Symfony or another application that's replaced PHP sessions with their own session management, they're going to support Redis. And I install Redis on every PHP project I work on. My usual database order of operations scaling up is like SQLite, because that is like the most simple kind of file database you can start with. And the next step, by the time I have created a Docker Compose file for a Dockerized project, I'm going to add Redis as my memory layer, and it's something you can do in 4 lines. This Docker Compose service here is a complete definition for a Redis service. If you wanted to make it persistent, you just add in a named volume. But even for Valkey, Dragonfly, or Microsoft's Garnet, we're all talking the same kind of simple, low-effort integration to get that up and running. You do need, you should, you don't have to. There is Redis, which is a composer userland library to work with Redis and PHP. But really the recommendation is to always use PHP Redis, which is installable through Pi in a 1-line, or you can get it through Peckle as well, and that gives you PHP extension C-Speed with Redis or Valkey or Dragonfly. All Redis OSS databases are supported through Redis. So let's talk architecturally what this kind of looks like. At its core, these in-memory data stores have a single-threaded event loop. And yes, single-threaded in 2026. We'll get to that. It's a feature, not a bug, I promise. The data, 100% of the data lives in RAM, as opposed to MySQL Postgres, where your data lives on a disk and it's a I/O operation to read off of the disk into memory to read that data back. The Redis OSS compatible databases all keep 100% of the application memory in live memory, which is super fast. Persistence is optional. Typically, there will be a way to snapshot that back to disk or an append-only log, which means that it is persistent. The Redis and its clones are ACID compliant, with a slight asterisk, but they're mostly ACID compliant. And they are very much atomic in that ACID compliance. One command, one operation is going to run to completion before the next starts. So taking advantage of the single thread is you will not get race conditions where you have overwrites for single key operations. If you have multiple operations, you can wrap that into a transaction. That transaction becomes atomic. It's very, very simple. And under the hood, there's a wire protocol, RESP, that allows various clients from the CLI to PHP Redis to Valkey's new client that they're launching for PHP, or in the process of launching for PHP here in the next couple of weeks. So again, single-threaded. That's weird. 2026, we're used to, especially in PHP, we're used to be told that it needs to be asynchronous. You need to have multiple threads running. But the advantage is no locks, no context switches. It's very simple. By optimizing the storage and the event loop to an incredible, and Redis has been around since 2009. 2009. By having that optimized to a just insane amount, we don't need to have locks and context switches. It is good enough to have on a single thread, which also makes it nice when you're running in like a Docker Compose situation. It's not going to be sitting using up a bunch of CPU. And really, the bottleneck for a Redis OSS compatible database is not going to be the CPU. It's going to be network latency, or your memory. Memory is expensive. Like that's the bottleneck anymore. It's your RAM. RAM's going to be your bottleneck. But even on commodity hardware, we're talking hundreds of thousands of operations a second. Now, when you do get to the point of needing more CPU, you can scale your Redis instances horizontally, or you can reach for a multi-threaded fork of Redis, which we'll get to shortly. So, quick note before we keep going, I do want to talk about data structures and not just DevOps stuff. I won't be covering deployment, clustering, sharding, replication, failover, or any of the fun stuff that the DevOps guys tend to work with. But you should know that Redis and its clones, they've got that well covered. There are good solutions in place for having these very mature applications deployed reliably. But let's get back to structures. And to get to the structures, we're going to talk about the family. I've said a couple times Redis OSS compatible databases, and I should clarify. Now, the first time I gave this talk, it was just Redis. This was a few years ago. This would have been probably 2017. It was just Redis. I could say Redis because there were no Redis clones at the time. And now we have a handful of clones: Redis, Valkey, Dragonfly, and Garnet. And really, Redis is still the gorilla in the room. Valkey is really nice. It would be if Redis took the Microsoft approach, Valkey kind of took the Linux approach to philosophy, to development. And Dragonfly is a relatively brand new, multi-threaded, but still atomic rewrite from the ground up that's still compatible. And Garnet is Microsoft wanting to do Microsoft things. There used to be a clone, a Redis OSS compatible database called KeyDB, which was also a multi-threaded fork and looked really, really promising. It was purchased by Snap with the promise of developing it, and then the lead developer left, and Snap has done nothing with it. So it's dead, which is unfortunate because there was some very promising looking work in there. But why do we have all of these various databases? How have we exploded out here? Well, Redis screwed up. There comes a time in a open source project's life where they grow a little bit too big and they get venture capital, and all of a sudden they want to make money. And sometimes the promises that were made about being open source don't make business sense to MBAs that get brought in. And so in 2024, Redis Incorporated switched from the BSD open source license to a dual closed source available license. Neither of the licenses, the RSAL v2 and SSPL license, were OSI approved, which caused some kerfluffle with like legal teams, because when you ship embedded product, and Redis is great for shipping embedded given how small it is, and how lightweight it is on an install. Legal teams have opinions about licenses, but so do nerds. And there is no way to get nerds riled up as changing your software license. And so within 8 days of Redis deciding to go to a source available license, the Linux Foundation forked the last BSD version and renamed it Valkey. And that's why we have Valkey. At the same time, because the writing was on the wall about where Redis was going with using a closed fork and essentially becoming more of an enterprise product. AWS, Google, Oracle, and Ericsson all backed Valkey. And even now, if you go to AWS and you go to set up a Redis compatible database, and there's several options, and they've got MemoryDB and Elasticache and Redis for Elasticache and Valkey for Elasticache, you'll find that Valkey is like half the price as Redis with essentially the same functionality. And that's all just a offshoot of the really bad 2024 decision to make license changes. So then in May 2025, a major contributor that was involved came back into the project and decided like there was a movement to fix this thing. So if you're going to go from one end of the spectrum back to the other, then going from a BSD license to a closed source or a source available license, then all the way back to the AGPL, and going that far back to a copyleft license is a pretty good walk back. Now, technically, Redis is triple licensed, and you have your pick of which license you want to license it under, which has always kind of confused me because it seems to defeat the purpose of licensing. But if it makes the lawyers happy, that's good enough. But this has left us with several compatible versions, all clamoring to essentially do what Redis does, but with a fixed or different license. And really, at this point in time, the architecture difference comes down to threading, with Redis and Valkey being single-threaded and Dragonfly being thread per core. Now, technically, Valkey has an async I/O threading for network handling, and Redis does have some non-single threaded operations with vectors, but it doesn't affect the single threaded nature of single key operations. So what we've ended up getting is Redis OSS compatible, where we have a world where the, say, traditional 10 or so data type, string list, hashes, set, sorted set, streams, bitmaps, hyperlog logs, the geo stuff, the REST protocol, and like the core commands to interact with Redis compatible. Those are all shared between a number of the clones, because that makes it compatible, which is great because those are drop in. At the same time, with Redis coming back, going AGPL, they ended up taking the stuff that they pushed into closed source modules like JSON, documents, query engines, time series, and probabilistic data types. And they, as of Redis 8, they moved into the open source project. So those are now available. So that's the real difference. So we're down to, and this is my decision matrix. For cost, simplicity, and because I like supporting the project, if I'm just going to use the standard core types, essentially, if I'm just going to use Redis as a cache and a couple other things, maybe, I'm going to choose Valkey and use that as the basis. If I want to do something more complex, vector sets, JSON, time series, I'll use Redis. Or if I'm just trying to make sure that I'm keeping in line with, say, I'm using another product like Light LLM, which has a Redis integration, and I want to make sure that it stays in line, I'll use Redis. I have not actually had the chance to use in production Dragonfly, but I'm assuming that if you're going to the point of needing maximum throughput, that would be the way to go. And then if you like C# and .NET, knock yourself out with Garnet. So we finally almost get to the data types. But again, regards to the clients, we're going to start with shared counters and locks. You have many PHP workers, many servers, and we're in a distributed environment. We scale up. All of those servers are trying to read and modify the state of data. So we really want atomicity, and we want to avoid race conditions so that two workers will not increment and read the counter the same, that a worker will increment, the value will go up for the other one reads. There's no loss of rights. One complexity we do have to talk about, Redis OSS databases, they're schemaless. This is great freedom in that you don't have to come up with the kind of schema that you get with MySQL, Postgres, where you have fixed columns and types and constraints, and you need migrations to enforce it. On the other hand, you don't get that with Redis, so it's up to you to manage your essentially internal schema so that you know that in a key that looks a certain way, you can expect certain data. The first of the data types we're going to talk about is a hash, which is essentially a associative array where we have a field value map in a key. So think of it as like a key value database inside of a key value database. And newer functionality that's been added into Redis is now you can expire the individual fields without having to expire the entire thing. So that has made these hashes into coordination objects. So you can read and write this this object without pulling the whole thing into your client. That's the real advantage. If you're talking about the normal pattern that we've seen in PHP, and even with caching things in PHP with like the PSR simple cache and cache pool interfaces, you get the key, you fetch the object, and it's either PHP serialized or it's JSON it's JSON encoded. So you have to decode it, you modify the field, which affects the entire object, you encode it back, and you set it again. And now you've got a race condition, and you've got a situation where what if we need to update different fields of this thing, this key at the same time? Well, with a hash, you do one field and it can be done over the wire atomically, which allows for us to get rid of that application-side serialization, which is very beneficial when you're trying to use this as a coordination object. And one use case, the simplest use case for coordination object being rate limiting. And we can just really use a string for this. Redis, if you have a numeric string, you can increment it and decrement it. So it's a string 1 will get incremented to 2. And the simplest way with just a string is to set the key, set the TTL, the time to live, how long the key before Redis will automatically clean it up and expire. But if we want to go further, you can use a hash and store not just the last time that a request came through. You can store the window, you can store the burst. So you can actually use that hash to implement a more complex rate limiting scheme without having to kind of go crazy with schema or logic, or without really pulling it into your application layer. And if you want to go even further, Redis supports Lua scripting. And if you look in like the Symphony lock package or some other common caching packages, you'll see that Lua scripts are used for more complex locking and rate limiting because they allow references to essentially things like fetching the value of a key into another key. I don't use it that much, and to some extent it is being replaced by Redis functions, which is another one of those DevOps things we're not going to get into. But it really does allow for a lot of extra functionality and essentially the logic to live at your database layer and not to live in your application layer. So moving on to our next problem class is the checking what is efficient in a set. And I called out efficiently checking membership in massive sets in the abstract for this talk because this is what made this click for me. This was the application that made Redis OSS as a data structure database make sense, and we'll get to the example there. But in general, we're going to talk. There's three kind of super types here to talk about when we're talking about membership. One is the set. That's going to be your base data type, because that is what a set is. A set is membership, where it is a unique group of things, and uniqueness is the aspect of a set. That's, you don't have a count of a set, you have cardinality. Then if that doesn't work, there's bitmaps. And if you have something that maps really well to dense integers, we can use bits and bit fields to map values. And then scaling all the way up. If you're at a point where you don't actually need an exact number, Redis has a handful of probabilistic structures. Bloom filter, cuckoo filter, hyperlog log, tdigest, top k, count, min, sketch, which I'm not going to get too deep into those, other than mentioning that those are things. Frankly, if you have a problem that needs those for a solution, you already know it. You are at the point of needing to deal with massive numbers, and where you don't need exact numbers anymore. So the base constant time is membership check in a set. Sys is member in Redis. It's just this is member function. It doesn't matter if there's one member of the set or 10 million. It doesn't really matter. What does matter is memory cost, because you actually do store the entire element. And for me, the example that really kind of kicked things off, it was a number of years ago. I was working with a client that was working with the United States Do Not Call list, which has hundreds of millions of phone numbers on it. And they needed to essentially have a fast lookup of, is someone's phone number on this list? And at the time, they didn't have Redis or anything. They were starting with MySQL. So if you were to take I think it's 300 million, it's a lot of phone numbers on that list, and you were to put the phone numbers into a MySQL table and index it well, you're going to get a 12 gigabyte, at the time, a 12 gigabyte table in MySQL. And because even at O of log n, you have enough elements that you're not going to get a fast lookup, even with the index. So in trying to solve this problem, my next thought was, Redis, bring Redis in, because I'd heard about it at PHP Tech that year for this sort of thing, at a talk at PHP Tech. And it put the thought in my mind to look at it for using sets, but it was still way too big because we were storing all of the phone numbers in the set. So even though we had solved the fast lookup, it was still a ton of memory. So the solution ended up being using strings. And this is a solution that a bit of Googling, I found a article, I think it was actually like Indian phone numbers, organizing Indian phone numbers like this. But you don't want to have a single key. You need to bucket break down the list into buckets of keys. And we decided we're going to do that we're going to take the first 6 digits of the phone number and make that part of the key. So then we only have a million possible keys. And then because Redis is binary safe and you can store bits as the value and do bitwise operations, we use the last 4 digits of the number to set the bit at that position, which means we had a maximum of like 1,000 bits for each of the buckets, which ended up being 2 orders of magnitude smaller. So we went from 12 gigabytes down to 150 megabytes in memory with constant time lookup. Because getting the bit at an offset is constant time. It is super fast. That just made things click for me as far as like seeing that there's so much more for this kind of database. And then once you get a bit or bit field, because you can operate on bytes as well, so you can store like groups of flags for a user by byte offset. Redis has recently introduced a bit ops. So you could take 2 keys and you can do and or on the keys and get the result without writing it or pulling it down to your client. So if you were using a bit field or bitmap to track users active in a day, you can use bit op and across those days to get the and that result, and then you can check how many bits are set in that result, all without pulling it down to the client at ridiculous speeds. That was really, and as someone that just loves bitwise operations and inordinate amount, this was so cool. But then again, if you're past that point and we're not even talking about exact answers and you just need things at a level of probabilistic assurance, there are structures for essentially eliminating false negatives and false positives, the Bloom filter and the cuckoo filter, hyper log to find out how many unique or estimate how many unique items are in a set with only taking 12 kilobytes for a billion entries. And the other structures like top K and count min sketch and T to digest to do various probabilistic things that frankly I've never had a reason to do, and I'd be scared if I ended up needing to out of the blue. But if you need it, they are there. And then our next kind of sphere of types is our ordered data, where we talk about rank and time and space. Membership is whether something is there or not. This is where something is in a list. And the data type, the data structure that does the most work here is going to be the sorted set, where it is essentially the marriage of a list and a set, where you get the membership assurance that a element will only ever exist once in that set, and then it gives you essentially a ranking similar to how a a heap will give you the top or bottom value. But in this case, it's fully sorted efficiently. So it has that extra property to it. And this ends up being really flexible. I've used this for a number of things because every value in a sorted set has its essentially the field. So you have a key called leaderboard weekly, and you've got the field player 1, player 2, player whatever, and then the score. It's going to be a float, and there's a number of things that just fit wonderfully into that float. One of which is the time. So it's really easy to get a time-oriented, time-sorted structure, and it's from there a very easy step to get to a time windowed feed where you can add things onto the set as you go and then cut it down to a particular window. This is also a way of doing rate limiting or top scores, or it's a, I'd say, more accurate way of doing that rate limit, a sliding window rate limiting than the increment approach. But it's still atomic with the z increment by method to increment a particular score. Then one offshoot of that sort of set is GeoSearch. Under the hood, the GeoSearch functionality, the GeoSearch data structure in Redis is a sorted set. So you can do all the sorted set functionality with it, use the same sorted set functions on it, but it works with geographic data. So if you have latitude, longitude, it's really simple to find all the drivers of within a circle or square of a particular point in sub-millisecond speed. And if you're managing this, this is definitely something where you want to keep the logic not in your application level, and it doesn't work well with a MySQL database. This is where you're feeding this logic into Redis, managing the keys of who's active and who's not, and then you can just run these queries against the Redis database and with sub-millisecond speed get the results of all the drivers within so far of a point. And then it's worth mentioning lists. Lists don't get used quite as much as they used to. When I first started working with Redis, list was how we did queues. It's a doubly linked list. You can access it from either end. You can push, you can pop. There's blocking pushes, blocking pops. This has kind of been supplanted by the next data structure we're going to talk about, but it's still good for some things. Twitter used, or Twitter used this to manage a user's like the number of posts that show up when they first log in, limited to like 800. They build up a list of up to 800 items, and they just take the top so many, and then by persisting that list, no matter how many things they added into the list, and by then taking the first 800 elements, they easily got a distributed subset of that list in memory for quick access, and then expired it after so long if someone's not active, because that was rebuilt anytime someone logged in. Now, the thing that has supplanted the list for list-like operations, queue-like operations, is the stream, which is an append-only log. It's a little bit like Rabbit. It's a little bit like Kafka, where essentially you have a worker subscribe to pull messages off of it. It's got the benefits of acknowledgement and claiming and pending and all that good stuff. I've used this under the hood with Symfony the message bus, and something else escapes me at this time, which is great for managing server-side events. sending server-side events in and emitting those back out. But really, once you get something more complex than that, just reach for Rabbit. Like if we're talking about the point of like fan out or needing to manage dead letter queues and stuff, Rabbit, Kafka, at that point there are better solutions. Speaking of better solutions, Redis 8 brought us the things that Redis originally had in their closed source module, and of interest to us, the JSON objects, JSON documents, time series, not so much, but still worth a mention, and vector sets. A couple years ago, those were all commercial licensed, need a separate install, payment. Now that is just part of the core, and you'll see that Valkey is catching up. Valkey already has some of these in their own modules that are available, and eventually that probably will end up with parity as we see the OSS compatible instances catch up. So similar, just like the MySQL JSON extension, just like MongoDB, you can work with JSON documents like by path. In this case, you do get path-based atomic updates given the way it's stored under the hood. While you can still fetch the whole document under one key, you can increment, append, operate on the object in an atomic individual way. Time series. If you're trying to do something like Prometheus or sample within buckets of time and aggregate, you should know that this is an option and is part of the core. Probably if you want to do something like Prometheus, just use Prometheus. The advantage here is you already have this Redis instance running, and it's easier to play around with. Like just fire up the console to mess around with Redis to test stuff out. And so in the couple minutes we have left, because I know I'm a bit behind here, we got to talk about AI because 2026, and there's no way not to talk about AI. And where does AI and Redis intersect? It's going to be similarity search. It's going to be vectors. It's going to be caching. When you send a prompt to an LLM, it can benefit from context. Retrieval augmented generation. It's a pattern where you fetch out relevant chunks of information based on semantic similarity, not just keywords, but semantic similarity to information in the prompt, inject that back into the prompt so that you essentially enlighten the prompt for the AI to work on. Essentially, you embed that query into a vector, you find nearest neighbors some way, and you inject them. Now that vectorization and the find nearest neighbors, the fancy math part, realistically at a production level, it needs to happen in milliseconds. It's a hot path. That's happening every prompt. So we now have specialized vector databases like Pinecone, Weave8, Quadrant, but Redis has brought this in natively, which gives us Redis speed and the fact that we already have Redis, that advantage. So just to quickly go on what is a vector and what is an embedding. So an embedding is just an array of floating point numbers. It can be like 386, 768, 1536 numbers. It's dimensions. We're talking multi-dimensional, higher dimension, brain screwing, mind-boggling math. And by evaluating cosines and doing more fancy math on these arrays of floats, we can find out, we can find things that are similar to other things. So king and queen as words are going to be close together, but king and bicycle are not, because they aren't similar, But king and bicycle might be closer than king and refrigerator because bicycle playing cards are a thing, and king is a card rank in a deck of cards. So Redis has technically two ways to do vectors. There is the query engine, which is the more mature, older way of doing it that's been around for a while. And the new thing in Redis OSS 8, vector sets, which is in my mind, it is the cooler one to do, because it lets me do things that like other people think you have to use Python to use. Both use a hierarchical navigable small world index, a skip list for navigation. And now we have dedicated vadd, vsim. We have dedicated vector methods in Redis, which makes this actually fairly easy to use. What the pattern looks like is you get an embedding from somewhere. PHP doesn't have embedding libraries like Python does, but let's say you are running an embedded model on locally and doing an HTTP query to the model, or you're running Python locally and shelling out to it. Somehow you get that embedding, that list of floats, and you can insert it with vadd, and you can find matches with vsim to get that back out. So the payoff here is that you get non-exact matches. So you can do semantic matching of something like how tall is the Eiffel Tower and Eiffel Tower height. Those are two different strings. Those would be a cache mix, but essentially those are the same question. You want the cache response because tokens are expensive. And why give Anthropic and OpenAI more money if you can just do this local, if you've already run the query, if the query is close enough? Because at scale, you're probably going to have a lot of AI prompts that are very similar and over time don't need to be rerun. And so having this essentially baked in semantic caching functionality powered by vectors in Redis is a huge win, which we can do in like 20 lines of PHP. It's pretty, it is essentially really standard for PHP, for like a PHP code, which I've been told you can only do in Python, or we have to use something else. We can't use PHP because PHP is not an AI language, which is not true. We can get the embeddings from models, and realistically, yeah, at scale, you're going to be using an embedding service or embedding model. In my local testing, I'm running the embedding model on my DGS Spark device and making a curl request to it to get the embeddings. But then everything else in PHP is so standard, where we get the hits and we see if it's already loaded. Essentially, it's that check cache, and if the cache isn't set, we load everything back into the cache to set attributes, and we can do it in 20 lines. And so adding this into even something that isn't AI specific, like something that isn't the RAG generation, if you just want to add this sort of like into a PHP application, is quite simple. So zooming out, there are other solutions, but realistically at this point, the payoff here is you've got one database that's handling your sets and your lists and your JSON and your streams. And so you can use this for multiple things, and the agent only has to understand one technology, which helps because context is also limited. So instead of using 10 different tools, the agent has a set of tool registries. The list can be used for chat history, we're using JSON data, JSON documents for state and kind of working as more of a more AI native hash, if that makes sense. And then logging with the event logs, and then the vector sets, the big win being the kind of long-term memory. But again, if it's Redis isn't always the answer, and like there are times where, yeah, you probably should just use Pinecone and go for the more traditional like AI stack of Postgres and Redis and Elasticsearch and Pinecone and Rabbit and Mongo. But that's still a lot, and especially if you're just doing a proof of concept, that collapse stack has a significant benefit. Add on that Redis speaks AI. Redis, even though they've moved back to the more of the open source world, they are still very much a for-profit company. And if you go to their website right now, there is a flashing circle icon about Redis and AI, and it is just splashed all over their website about Redis and AI. But really, Redis does have AI tools. There is a Redis MCP server. There is a set of Redis skills, which is actually really nice. And typically, I would choose just anymore. I would choose the agent skills over the MCP to minimize the effect on context. But it's drag and drop, simple to set up, and I've used that here in building this talk and in building examples to work through. It's really a no-brainer just to implement or pull in the Redis skills, which work with Claude and context, and essentially any other agent that follows the agent skills standard. So that's the tour. Redis is 18 different structures, strings, which essentially key value. That's the cache part. But on top of that, the hashes, the lists, the sets, sorted sets, up to the vector sets are really what power these data structure databases. And if you take nothing away from this talk, other than pick the structure that matches the problem, and maybe it's not going to match the problem for forever, but having that flexibility to think in terms of structures instead of just table rows and schematic data is going to be beneficial. You can choose what you need. Again, probably just the simple choice here is Valkey as a default. And then if you actually want to use the vector stuff, go with Redis. And then the Redis 8 OSS editions of vector sets and JSON make Redis more compatible with AI than I think has been given credit for, where it probably should be mentioned in the same breath as like Pinecone for this sort of thing. So that is essentially my presentation here. Again, my name is Andy Snell. I am WickedByte. I am a independent fractional software engineer and consultant. I help with Redis, Valkey, agentic development, PHP. I know I'll keep doing it, but I've done quite a bit of legacy code maintenance and upgrades. I'm happy to keep doing that. I am currently accepting new clients. So if anyone is interested in talking with me about that, I'd be happy to chat. And then questions. I need to get the companion and slide code up. I don't have that quite yet. I was working on tweaking these slides for PHP Tech. I'll be giving this talk at PHP Tech next week, but I should have slides up here within the next day or so. I'd be happy to take questions or turn it back over to Ian.
For folks here in person at Austin PHP, checking to see if anybody has questions here.
This is maybe not really something you covered in your presentation, but what's your kind of take on the performance characteristics of Redis versus using a database like MySQL, but an in-memory table?
So the question was, what's your take on performance comparison between using Redis and using an in-memory table on a traditional RDBMS?
Okay, that is a good question. And I think it has to be stated that no matter what someone promises you for throughput or Big O or anything else, the only thing that actually matters is your benchmarks, and your benchmarks need to mirror reality. If you benchmark it and a in-memory table in MySQL makes sense, as far as performance, go for it. As far as I'm aware, that in-memory table is still going to structure its indexes as B-tree instead of the it's not a straight hash table. It's the way that Redis achieves constant time lookups for its keys has changed over time, but it's highly optimized to get a constant time lookup of the keys. I have a feeling that matters at scale, that you almost, the in-memory part isn't quite as important as the constant time lookups. And mirroring that with, even though I say Redis is in memory, it's still persistent. It's still either through append log or through, I think it's RDB, writes back that information to disk as well. So it's persistent as well. Now, you asked about performance, but I think it is worth mentioning that it's both in memory and persistent, unlike a pure in-memory table.
I mean, Postgres has hash indexes. I'm not sure if MySQL does. Maybe it does too.
I think that is something that Postgres has that MySQL doesn't. And I think part of that is I've been a MySQL Maria person for quite a while, and it's only with essentially LLMs pushing their preferred stack, which includes Postgres, that I've started to use that instead of my MySQL. But then I think it also comes down to the structures, and there's a lot of things that you don't necessarily need a table for, and maybe a hash makes more sense for it. Now, if it is just tabular data and you want it to work like tabular data, that can work as well. And really, there's something that says you can't use both. It's a very common pattern to use Redis as your fast memory and back it with the database. So I've done this quite a bit with the PSR cache pool interface and simple cache, where you hit Redis first, and if it's a miss, you load it from the database, load it into Redis, and return it. That way it gets loaded in the future. So Redis essentially becomes your hot memory.
Cool. Well, I think we've got a whole bunch of people saying thanks in the chat and no questions further there. So with that, thanks so much for presenting, and for all those of y'all who have tuned in online or showed up in person. Thanks for attending Merge PHP, and I will see some of y'all at PHP Tech next week.